Okay, I was going to talk about the basic positioner that's in the S110, the S120 drive, same positioner. Um, and so, anyway, let's look at a couple things. Uh, there is a very nice manual that if you're going to do the basic positioner, you should go find, download it. Uh, This is the deal. I guess the CU 250-2. They were planning to have the basic positioner in there. I've actually never looked to see if it is in there. I guess I could always try to insert a drive and see if it's there. Um, Maybe we'll do that. But I know it's in the S120 and the S110. Um, so just search on the basic positioner ePause function manual and download this. This is a great manual. Uh, Everything that I'm going to touch on is in here in detail. Timing diagrams. The positioner is quite uh, advanced in the fact that it has all kinds of different positioning modes, tables for executing table moves. Um, uh, so this is a must-have. Yeah, go find this guy here because I've actually before I found this, got it working, but it was a lot of trial and error and trying to figure out why something wasn't working. um, so anyway, that's the ticket. Get that guy. Let's see here. Let's open up. This is the project I have. Actually, this is another kind of a junk project, but hey, let's try that. Let's see if we can find. It'll be a G120 is the base unit. Let's see, we got the yeah, okay, we'll just pick this guy here. It's the control unit that plugs on the front of the power unit is a 250S 2 Profinet version vector. Latest version there. I don't care. I don't really have one. We're just gonna see if we can configure it with the basic positioner. Go ahead and configure the drive. Pick any old drive there. Wonder if it's gonna want us to have one of the. Well, let's just try with the basic power module. We'll go back if it doesn't have it. Okay, put that in. Alright, see what we can do here. Let's go ahead and fire the wizard off. Let's, okay, well, it would definitely be dynamic. Oh, well, yeah, there we go. We got the basic positioner. Technology controller, that's the PID loop, independent PID loop that they got in there. This just gives you more monitoring and stuff. It's usually good to have that. This is free blocks, adders, subtractors, timers, stuff like that. To put it all in there. Okay, this is macros for common type things. Yeah, we're just whatever. None of this matters. I want to see go right to the basic positioner. I'm going to tell it it's got drive click. Then it won't ask me any of the motor data. Current 1 amp. Wind speed 1800. Just I'm putting stuff in here to get through it. This doesn't much matter. Identify. Inhibit that. Just If you inhibit the auto tune, then it just doesn't harass you. Okay, and so there is the basic information for the basic positioner. Load gear, position tracking, active, rotary axis, linear axis. Alright. I've never actually looked at this before. Technology controller. Where's it going? Oh, technologies. There we go. Basic positioners. There it is. That's actually, yeah, looks like the same thing. This is an S1 for, yeah, it's the same positioner, which is good. It's a nice little positioner. It's free. You know, depending on the motor, it might not be quite as dynamic as the S drives, but the G drives have really come up in their dynamic response. So probably you wouldn't see a big difference, you know, unless you're really on the bleeding edge of motion performance. So yeah, that's the same old end of travel stuff. Here's our okay. These are position jogs versus the velocity-based jogs. These are position rate jogs. Hey, there we go. You can configure your speeds for your jogs. There's a little jog ramp rate. Okay. Wow. It's all there. And of course, this is all explained in that manual that I was talking about. Um, as you can see, just me clicking here, there's a lot of stuff here. All the different homing types. You know, this is pretty much 25 years of servo positioning technology that they've kind of rolled it all together. You don't have to pay for it. Um, you know, from literally 25 plus years ago when they were really breaking into the CNC market and the automotive industry and the CNC world. So you get it for free, and it looks like you get it in the S250 or I'm sorry, the G120 with the 250S front end on it. So that's the brain part that plugs onto the base chassis of the G120. Okay. Here's the mechanics. Yep, this is where you set up all your scaling. So you scale how many turns of the actual motor and the motor encoder to how much your load actually moves or rotates. Uh, that's a whole subject in itself, but pretty standard in motion if you've done any other motion. Uh, Position pepper. Okay, so we got differentials. Yeah, so you can do basic registration control. Again, I'm not sure exactly how dynamic this is. I know this controller's base processor uh, loop is a little slower, but again, it probably doesn't matter for 99.9% of the apps out there. You're following your cam switches, position cam switches. Oh, wow. So, well, anyway, that's how you put in a drive with a basic positioner, and that's the same way you do it with the S120 or with the S110. So anyway, I wasn't going to go into great detail of that anyway, so I just wanted to show you that. This isn't really meant to be 100% a tutorial on how to do it. It's just sort of the tips. Like get that book, read that thing. It actually goes through all the commissioning of the drives and that in great detail. Uh, so if anything's hanging you up, you can just jump to that reference, and it's laid out really logically. It's more tutorial style than um, some of their other manuals, which are really can be pretty long and dry. This one's really kind of set up to uh, bring you through each step of the way you would set up an application so that you don't have to actually know everything. One of the problems with a lot of the Siemens manuals is everything is in the manual, and it uh, is a lot to plow through, usually just to get to a few simple things that you needed to know or one thing that's hanging you up. Uh, so that's why this manual is great, because there are, there's details in the function manuals, right? But you can see the function manual is, 732 pages long, and it's not uh, written as a tutorial. It's written as a reference. Um, Basically, you already kind of supposed to know where you're at, and you're looking up some sort of uh, detail that you just couldn't recall, um, and so that leaves people kind of on a very steep learning curve, and they're frustrated. Like, oh, I can't read 732 pages, and there's actually another book that goes along with that has other details, and it just overwhelms people, overwhelms me. So anyway, I was going to show just the basic. This one I'm just doing, as they call them, NDI moves, direct uh, motion moves. You give it a motion position, and then you tell it to execute it, and it makes that move, that distance, and that distance, of course, is the scaled distance that you've scaled in the drive. Everything's scaled in what's called like a length unit, which is basically, uh, you scale into tenths of millimeter or millimeters or hundredths of a degree, whatever makes sense for your machine. Um, and then once you scale that, it scales the number of pulses that are actually coming from the feedback device on the motor to whatever the end machine scaling is that you've done. And the basic positioner, then everything is done in that length unit. XLD cell are actually in length units per second. Um, Distances are all in that length unit. Uh, One thing to be wary of is you go change the length units. Make sure that you've rescaled everything. Uh, and if you don't, you can get yourself in a little bit of trouble where you've maybe if you left made the length units change a lot. Uh, let's say like 2x or 4x or 10x type change in your scaling. Uh, Make sure you go retune the loops because they're based all on the same sort of scaling, and now you've made radical uh, difference in your scaling. Obviously, you're going to have big uh, differentials in your gains in that because they're all kind of based on the length unit scaling you had. And it's something I've done. I've realized I had the scaling wrong, went and changed it, fired it up. Now something that was extremely stable is totally unstable, and the drive trips. And then it's like, oh yeah, I gotta go back and make sure all the limits are right, and tune everything to make sure that the loop gains are reasonable for that length unit scale. But just to do an MDI move is actually pretty simple. Um, so this just, I'm making always on bit like everyone does. Just a little timer thing there. Um, Here's a little drive reset. So I reset the acknowledge bits in the drive. I happen to have two drives, although I'm only really running one now as a positioner. But I don't like to see faults, so I reset both of them to make sure the CU is clear. And then I got to make sure that the coast stop, the quick stop, and the enable is on. Because this is a demo, it's on all the time. I mean, obviously you'd want to drop that with your e-stop. Uh, but this is a tabletop demo unit, so I'm not really concerned with the coordination of this with the safety PLC and everything else. But normally you would do that. Um, make sure that a 0 in this bit means that I'm in MDI mode. It's the MDI positioning type. Again, refer to that book. Um, and I want to be in a direct mode where I'm sending it a value, not reading it from the tables inside the drive itself. We can set up tables to make MDI moves. Um, so a 0 there is going to, oh, sorry, a 1 there is going to give me the MDI move. Um, and then I want to make sure, actually this should probably say not stopped, but I'm not doing a stop of the move in the middle of it, which is something you can do. Especially for recovery in a real machine, you'd want to actually have this stuff, not just hard coded to something. Um, and I don't want to reject. If it drops to a 0, it rejects the move. Um, Again, these are things that when a guy hits an e-stop or has a setup, you'll want to reject whatever move was left and things like that. Um, and then I just have a bit, which I just have the HMI start the move, tell it to activate the ePause traverse. Um, well, because I had this on the display, I actually first start the drives. So obviously, the on-off bit, and then you hit the start to move. In fact, you could do something simple as say, hey, if this isn't on. Actually, there you go. That way, you have to start your drive before you actually execute a move. Um, like most servo drives, it has velocity, accel, decel, override values. Um, I got them set to 100%. So whatever the accel, decel, and that I actually have set in the drive, that's the accel, decel. Um, but this way you can actually, depending on the move you want to make, you may want to actually scale that, maybe 50% accel, or limit the drive to 25% of the speed by putting 25%, and then whatever the max is in the drive gets multiplied by that. Again, little demo, it just set to 16384. These values are 16384. They're actually set in the OB100, the startup. Uh, just moves the values in there. That way, it's always set to that while the program is running. I did have a little jog, so if I wanted to do a little position-based jog, I set that up. Um, this is just a block that moves all the data in and out that I wrote. That just uses the data structure, so everything has a name, just like it's named in the drive. Uh, then the drive tells me when the move's complete, um, or if the servo's faulted. All right, so these are coming back out of the drive, out of that communication data block. Like in a little previous video, here's the block that actually reads a CU320, because that's what I'm using with a couple S120 drives. So you can see it's actually really easy to do just a basic MDI move. And the drive is set up as default. I did tune it and I did scale it to something that I liked, and made sure that the limits were reasonable, the speed limits and the XL decel, the max speed. But other than that, the drive is set up as default. So all you really had to do is make sure these these guys, and this is in the timing diagram in that manual. That's how I actually said it. It had been a year or two since I've actually touched, probably 2 years since I've actually touched this. And I was like, I know they got that documented, and I went and found that. So there it is. Instead of looking back at the diagrams and trying to figure it out that way, I just said, hey, here we go. I'll just look at the timing diagram, and it showed that all I had to do was make sure that I wasn't stopping it or rejecting the move. In fact, I didn't set these, and it was doing that and it wasn't doing anything. I looked at the timing diagram and said, well, uh, look at the timing diagram and do it right. And it just started working, just as it's documented. I started the drive up, gave it a move. Now the moves are actually set from data that I write to the position and speed. I need to show that because it's not going to show up here. That'll be in the data block. There we go. Alrighty. So there's the data block. You can see that these overrides that I was talking about, V velocity overrides. Yeah, I got that. That's all it is I'm pushing 1024 into it. Then we got the position set point and the velocity set point. And if I go to display, I'll just stick something in there. Those numbers may be too big, but whatever. um, uh, those numbers now are getting directly set. They come right from the simple little HMI program that I have. So, um, so that's basically it. Often you use a move statement to move these values in there, but um, in this case, I just wrote them directly uh, to the data structure that I created. Okay, I put a number in that makes a little more sense for that move speed. I had the move speed so high that it moved almost instantaneously. So here I'm going to look at the status coming back from the drive. Uh, and you can see, and I'm just doing a relative move, so it just moves this value every time I hit that make move bit. And you can see there the drive's moving. Still, it's actually a pretty slow speed, so you can at least see the numbers moving here in the position actual. And that's pretty much it. I wish there was a way I could actually put this code up on the YouTube. I don't think there is a way of doing that, but anyway, you could always email me if you were interested. And I'm just gonna pop open this screen. Oh, screen. Screen. There we go. So all I'm really doing here is, this is bare bones manual type operations. So I start to drive, put some value in here, hit toggle that bit that makes the move. As soon as the bit toggles, that's when you see it moving in the data. There was that jog bit, and there was that reset bit in case of drive faults. Uh, so that's there's no reason to bother showing the video of the screen. That's all there is. No magic there. Um, so anyway, uh, that's the basic positioner. I think the whole key thing out of this is that manual and how simple it really is. So good luck. If you have any questions, you can always leave them. Thanks. Bye.